Hey guys, I thought I'd just make a quick little video about my autocollimator. So here we have the light source. I'm gonna take that apart in a second. A focuser, then the beam goes through that plate beam splitter. These are like super cheap, like a pack of 10 for 20 bucks from China. Then we have a carbon fiber tube. It's just for the light path to go into, and it's light and stiff and just overall good. Thermostability is pretty good. And then in front of the tube goes the lens, so it's in here. This is just a achromatic doublet with like 350 millimeter focal length or something. So that just slides in here, and then that's it. Then the light goes out the front, hits a mirror, comes back, passes through the plate splitter, back here. This is just a helical focuser again, to the camera. This is just a Basler sort of full HD resolution camera with a C-mount, and there's just a adapter to go to the 1¼ inch telescope mount. So yeah, and these parts are just 3D printed. That house the beam splitter and just connect all the parts, and I just put some bits in here to get rid of stray light and stuff. So this just captures that, and the angle here is to like make the light that comes in bounce back and forth to get lost basically. So this is the light source. Here we have the LED. It's just a white LED, pretty badly centered on the heatsink. I made a jig by now that I can do this better. And then this is just some thin white plastic to get a more even illumination, so I don't just create an image of the light source through the cross here. So you can see this is a 40 micron crosshair. These are like 20 bucks from China. This is 20 millimeter outer diameter. And yeah, this just projects across out, so I can detect it with the camera. And this works pretty well. So now I'm just gonna put all of this together. I wanted to show you this. So this is the view inside, like the end of the autocollimator, and you can see the cross in there that is coming from the reticle. So that is pretty neat, and you can see the inside of the carbon fiber tube. So it's kind of reflective, not ideal, but I don't think it's a real problem. So now we have this assembled. Entire autocollimator. I just set it on some blocks or Hein stuff I have lying around. And yeah, hi. This is just the mirror I'm using. It's a secondary mirror of a Newtonian telescope, and it works quite well. So I just made this mount that has like a screw in the back. It scratches a lot of surfaces, but you can like move it around and tilt it to like get a signal back, and to move it around, get a feeling for it. So now we are looking at my Python program. Right here you see it's throwing errors because it's not detecting a peak right here. This is quite a weird peak, and the image is tilted. So what we need to do is to turn the camera so we get the sharpest peak possible, or maybe right here, and then we get an output. So what you see is when I turn this, I can just move it through the image, which is quite nice. And obviously this is a very shaky setup, so if I tap on here, this all moves around. What I'm gonna do next is mounting this mirror directly onto here. So we have the shortest metrology loop possible, and then I'm gonna show you how stable all of this is. Also, just to show you, this is the telescope mirror. So now we have the mirror in its new mount. Please ignore the nut, that's what I had, so it works. So if we put this on here, we get a nice return. So now we are live reporting the values. The x-axis is in minutes. It's a bit weird unit, I have to admit, but it's what I have. And this is arc seconds. This is left to right, this is up and down. So we have some thermal drift right here. But this is surprisingly stable, so noise is usually within a few tenths of a arc second. Like this is a tenth of an arc second, this is more. Don't know why, honestly. But yeah, this is quite good. So sub arc second noise. Of course, thermals are an issue, so camera is heating up and stuff is moving around, but it's doing quite well. I'm surprised how well this works. By the way, 1 pixel is about this much on that scale, so about an arc second is 1 pixel on the camera. I've tried a lot of different image processors to like get the best performance out of it and most FPS and stuff, and it's been quite the journey, and software has been by far the most difficult part of the project. So right now I'm gonna leave it as it is, and when I need it I'm gonna add features that I have use for. So I hope this has been interesting. I quite like this thing. I just need a use for it now, since building the DTL will take some time. So this is gonna go on the shelf and wait until I need it. Anyway, thank you for watching, and yeah, have a good one.